Yes. Good morning. The topic of our presentation is ENSO and sea surface height change. This is the index of our presentation. Okay, before we go into start relation between ENSO and sea surface height, we have to understand about sea surface height. First, the definition of sea surface height, also commonly called as sea level. Sea level is the level of the surface of one or more of oceans, from which height such as elevation can be measured. The height of the sea level is caused by gravity and active ocean circulation. And normal flow, regular circulation pattern of sea surface height move up and down with the normal progression of the season. Using theory of ocean dynamics, sea surface height can be used to calculate how much heat is stored in the ocean below. And it can change in the ocean that indicates climate events are dramatically visualized by these data. Okay. Secondly, ocean has heights and lows similar to the hills and valleys of Earth's land surface described on topography map. Similarly, ocean has own topography. By collecting data from sea surface height, ocean surface topography data has significant practical application in such areas as weather forecasting and climate forecasting and monitoring changes. This figure shows sea surface height anomaly, and the difference between what we see and what is normal for different time and regions are called anomaly. When oceanographers view these anomalies, they can identify unusual patterns and can tell us how heat is being stored in the ocean to influence future planetary climate change. So, how do we measure sea surface height and sea surface height anomaly? There are many ways to measure them, but we choose two representative ones. First, let me introduce tide gauge. Tide gauge, which is one component of a modern water level monitoring station, is fitted with sensors that continuously record the height of the surrounding water levels. The left one is an old one before the computer was invented, and this one is right one is a new one with new technology involved. But this measurement has a disadvantage. Because it is too local to measure. We have to look more broadly, like a giant scale, to look El Nino and La Nina. So let me introduce measurement, satellite measurement. This figure is less. Sorry. You probably seen this figure in last class in geostrophic current. It was in the study guide. This final exam range. Okay, so we are going to get. I'm going to explain it brightly. Satellite measure the center of the mass of the Earth, ellipsoid. One effect of this is that as the shape of the ocean basin is changing slowly with time, a correction needs to be made to be altimeter data for this. Finally, this is also in the final exam study range. Yeah. So we can study accuracy, sea level change, seasonal cooling heating, variation of sea topography, information about how much heat is, and except one thing, this is not in final exam, but with sea surface height anomaly data, we can find the determination of potential fishing zones. For example, yellowfin tuna. The figure of the below, that one. This is the performance of yellowfin tuna, which related to sea surface height anomaly. And now I will explain ENSO. we have to study ENSO because it has strong relation with weathering change. Picture on the left side is drought in Australia and the other is flood in South America. These two weather phenomena are affected by ENSO. And then, what is ENSO? ENSO is abbreviation of El Nino Southern Oscillation, literally. ENSO has three phases. One is normal phase, and second is El Nino and La Nina. This is normal phase, which has normal upwelling, trade wind, thermocline. But in El Nino, trade wind is weaker. This is weaker, and the gradient of thermocline is low. And La Nina is opposite of El Nino. It's increased the gradient of thermocline and strong trade winds. This is ENSO. These three phases becomes making oscillation. So with this, in this graph, ENSO is rapidly occurred and recently. El Nino phase become frequent. And then relation between ENSO and sea surface height. This figures is from NOAA, and this picture has information for the last 5 years at equatorial part of the Pacific Ocean. It has 15-16 El Nino data when you see this graph. You can see the sea level rise at El Nino period. Let's wait over there. Oh, let me see. This part, you can see. This part, yes. You can see the sea level rise on that. And here we provide side-by-side comparison of Pacific Ocean. During the famous 97-98 event, which was Super El Nino, which is A, and 15-16, which is B. A El Nino picked up in November 1997, and the B El Nino which peaked in January 2016. And B was longer lasting and larger in area than the A episode. The A El Nino was followed by a strong La Nina event, while a La Nina followed at B El Nino, reminding us yet again that each El Nino event is different, but both El Nino cause great damage to mankind. To prevent this El Nino, we have to predict El Nino. During research for presentation, our members have learned that with sea surface height data, we can forecast El Nino and La Nina. So our team was so curious in whether that was true, but we found interesting things. There was no information related to sea surface height. We read lots of papers of 100 pages that there was only papers related to sea surface temperature. We know that sea surface height anomaly related to sea surface temperature, but curious about why the scientists use only sea surface temperature. So one of our team members sent an email to this guy who read the report. And we wait about 3 days without sleeping. Then he finally answered that he doesn't know. He doesn't know why only use sea surface temperature. Actually, it's kidding. He said it right. He said the reasons why use sea surface temperature. Because sea surface height anomaly has lots of variable things, like tides and sea waves, or like that ones. So, in conclusion, through these things, we have come to think about limitation and advantage of sea surface height. That covers my presentation, and thank you for listening.